Remember, to simplify, the first thing you're going to look for is there a perfect square that goes evenly into it? Or yeah.
Say that we were all wrong.
Either you're all right or you're all wrong.
We didn't say all right.
I didn't say either way yet. All right, so the first one I'm looking at is perfect squares going into 5 or 50. Nothing really goes into it perfect square-wise, but it's probably a good idea to first combine them to see what their total value is. So that means put them underneath one square root symbol. So that would be the square root of 5 times 55. Well, 5 times 55 is going to be 275. I think 275 is a nice number because it's kind of one of those like 25. You kind of know when 25 is going to go into something, right? It's like 25s, it's 75s, it's 50s. So 25 must go into that. So we could say this equals the square root of 25 times, what was that, 11?
Yeah.
Times 11, which we can rewrite as square root of 25 times square root of 11. Which is going to equal 5 square root of 11. So you should have got 5 square root of 11 for that one, but that doesn't really help us with the next one because that's the one I actually checked. Now the next one, you kind of have two options. I'm going to pick the harder way first, but you're going to get the same answer. The harder way is to split this apart. I'm going to change it right away, so don't copy this down, but you can change it to square root of 14 over square root of 42 and multiply the top and bottom by square root of 42. Definitely possible, but it's going to be a much harder method than this method. So that works, but an easier way to do that is to notice that 14 over 42 isn't simplified. You can simplify underneath the square root because it's something underneath. So I'm going to reduce 14 over 42. So the first thing you might notice is that 7 goes into both of them. 14 divided by 7 equals 2. 42 divided by 7 equals 6. Well, 2 over 6 is also simplifiable to 1 over 3. Well, that's going to equal square root of 1 over square root of 3. So now is where I break it apart to the square root on top and bottom. Well, square root of 1 is just 1 over square root of 3. You cannot have a radical in the denominator, so you do need to multiply the top and bottom by square root of 3. And your n answer is going to be square root of 3 over 3, which was A. Everyone I scanned had A. Hopefully you meant to answer A. All right, questions on simplifying radicals? We're good? Okay, then let's go on to the Pythagorean theorem. I think yesterday we said most of us have heard of it, saw it, or actually know the formula. Well, the Pythagorean theorem, first of all, it has to be a right triangle. Don't apply the Pythagorean theorem to every triangle you see. It has to be a right triangle. Now, it is the square of the hypotenuse is going to equal the two sides squared and added together. So the sum of the square of the legs. So it's important to know what your hypotenuse is and what your legs are. Your legs are going to be your A and B. These are your legs. Not your legs, but the triangle's legs. And C is going to be the hypotenuse. I'm going to put two important facts of the hypotenuse. Two important facts about it is your longest side. It is always going to be your longest side. And it's across from the 90-degree angle. Now, I put both those facts up there for a couple reasons. Sometimes you forget what the hypotenuse is. Locate your 90-degree angle, go across, that's your hypotenuse. Why I put the longest side in there? In picture form, you don't really need to recognize that. You just need to recognize it's across from the 90-degree angle. However, I can give you a triangle, and I can say you have triangle 3, 4, 5. Which is your hypotenuse? So I have a right triangle, 3, 4, 5. You don't have a picture of it. You have to be smart enough to recognize, okay, 5 is the biggest number, so that has to be your hypotenuse. So if I just list sides of a right triangle, the bigger side is always going to be your hypotenuse. Don't forget that. All right, so then it leads us to this formula. This is the Pythagorean theorem. That is that a squared plus b squared equals c squared. That is your hypotenuse squared equals the sum of your sides squared. Now, before we're going to use this, we're in geometry, and geometry is filled with proofs and stuff, so we're going to prove it first. But it's not going to be like a two-column proof. This is what's called like a geometric or an algebraic proof. We're going to look at it picture-wise and area-wise, and we're going to actually solve for a squared plus b squared equals c squared. So that leads us to these two shapes. These two shapes are both a plus b by a plus b, and this one's a plus b by a plus b. So these are the exact same size. Do we agree that they're the exact same size? I have the exact same letters on all of them. They're the exact same size. That means both their areas must be the same, right? This room is the same area as the, maybe not that room over there, but if it was identical, it would be the same area. Now, normally I would do a plus b times a plus b, but I'm going to break this apart. I'm going to look at two different ways to look at the areas of these two shapes. So on this first one, what I'm going to do is I'm going to connect those dots like this, which creates four different rectangles. Actually, it's two squares and two rectangles. Remember, a square is a rectangle. Now what I'm going to do is I'm going to get the area of each of those parts. I'm going to add them all up, and that's going to be the total area of that shape. So if we look at this top left, I have a side A and a side A. So the area of that little square there would just be A times A, or A squared. Remember, area is length times width. Well, I can do the same thing for this bottom right one, which is going to be B times B, which is B squared. Can someone tell me what the area is of this top right rectangle? Emma?
AB.
AB. A times B, which means the other rectangle is also A times B because it has side A and side B. So our area of this rectangle is going to equal all those areas added together. So that would be A squared plus AB plus AB plus B squared. But it might be a little easier to write it as just A squared plus 2AB plus B squared. ¿Qué pasa?
Would you not put all the squared ones first, and then the one that's...
Typically, you don't. And the reason why we also use this to prove that A plus B times A plus B equals A squared plus 2AB plus B squared. It's just kind of like, you know when you have like a binomial times a binomial?
Yeah.
Just the order it lays out in is actually this order. So this is more traditionally how you put it. There actually is no rhyme or reason how you can... Let me take a step back. You can write it as A squared plus B squared equals 2AB. This is just traditionally how like a math book would write it.
Yeah.
Because they like the squares on both sides and they're combined stuff in the middle. But it's not going to change the problem at all. Okay. We said this one's going to have the exact same area, correct? Because if I drew the lines the exact same way, if I drew that across and this across, we would have the exact same thing. However, we're going to draw this a little bit different. Still the same shape, but I'm going to draw a box connecting inside of here, where I now have four triangles. 1, 2, 3, 4 triangles. All these triangles will have the same area because they're both, A is one leg, B is the other area. And we have this square in the middle of it. I'm going to do the same thing. I'm going to get each piece's area, and I'm going to add it together. Can someone tell me what the area of a triangle is? How do I even find the area of a triangle? Yeah. Yeah, half a base times height. So the area of a triangle, area of a, let's just use a shaped triangle, is 1/2 base times height. So if I'm looking at that top triangle there, right here, I'm going to call A my base and B my height. Doesn't matter what order you put it in. But that means the area of that triangle is 1/2 A times B. But this is the same exact shape. So this is also 1/2 A times B. Which means the bottom left triangle is 1/2 A times B. which also means that top left one is 1/2 A times B. So now I have the area of all my triangles. I have 4 of them. So we're going to add those all together in just a second. Now I want the area of this. Well, this length, I don't know this length. It's not B, it's not A, so we are going to name it C. We are going to name that side length C. So we're going to call that length C, which makes this length C because they're all the same length. So that means the area of that inside square is C squared. Now we're going to get that total area by adding everything together. So I'm going to have a C squared. I'm going to have 4 1/2 ABs because those are my 4 triangles. So our area is going to equal 4 times my triangle areas, which is 1/2 A times B, plus that big rectangle, or not, well, it is a rectangle, more specifically a square, C squared. So that area is going to equal 2AB plus C squared. But we started off this whole thing saying that this area equals that area. Right? We all agreed that this area, this total area, has to equal this area because they're the same shape. So, since the areas are the same, we can set the 2 equations equal to each other. So since the areas are the same, we can say that A squared plus 2AB plus B squared needs to equal this 2AB plus C squared. One area has to equal the other area. Well, there's one thing we can do. We have 2AB on both sides. So I'm allowed to subtract 2AB from both sides. So let's go ahead and do that. So if I subtract 2AB from the left side, I subtract it from the right side, everything's still balanced. And guess what I'm left with? A squared plus B squared equals C squared. In fact, anytime you see squareds in something, there's probably a rectangular proof that proves it is true, because squared automatically leads to areas of a rectangle or a square or a rhombus or something. I'm not going to ask you to prove this on a test or anything, but it's good we're in geometry class to see other proofs. This is 100% proof. If someone asks you to prove this is true, this works all the way through. You don't have to put any words. This is called a geometric or algebraic proof. I just use geometry and algebra to prove they are true. Any questions on that? Does that mostly make sense how I did it? Like I said, I'm not asking you to replicate it, but as long as you understand where everything came from. All right, since we're in geometry class, as soon as I prove something's true, we can go ahead and use it. So number 1 says find x by using the Pythagorean theorem or Pythagorean triples. What I want you to do right now is cross out that Pythagorean triple. We actually moved that section to a little later. So we're just going to use strictly the Pythagorean theorem. Pythagorean theorem says take your legs, square them, and add them together, and it equals your hypotenuse. So first let's locate our hypotenuse. Our hypotenuse is across from our 90 degree, so our hypotenuse is 5 squared. So we are going to have our legs, so that'd be x squared plus 3 squared equals 5 squared. Well, now we're just going to solve for x. 3 squared is 9. 5 squared is 25. Subtract 9 from both sides, and you'll have x squared equals 16. However, I did not ask you to solve x squared. I asked you to solve for x. Right now I have x squared. How do I get rid of that square? I have a square just sitting up there. I want it to go bye-bye. Krupa.
You find the square root of 16.
Yeah, you take the square root of both sides. Yeah, we take the square root of both sides. And we'll have x equals... Now, I want everyone to pay attention to this. If you're working on or further ahead, just pay attention to me for just a second, because this is important for you to recognize. In algebra, when you took the square root of both sides, more often than not, you should have had a plus or minus. When you take the square root of both sides, you should do plus or minus. In geometry, it is just the plus, because you can't have a negative hypotenuse. So when I do the square root of 16, it's not going to be plus or minus 16. It's just going to be positive 4. Now, a lot of you probably working ahead probably didn't even recognize it needed to be positive or negative in algebra. But don't forget that in algebra 2, they're going to go back to when you take the square root of both sides, it has to be positive and negative on both sides. Because a positive 4 squared is 16. A negative 4 squared is also a positive 16. But we don't have to worry about that, so don't worry about making that mistake. I'm just meaning in algebra 2, don't say, well, Mr. Pavian said I don't have to do the negative one. All right? I'm saying in algebra 2 you do, in geometry you do not. All right, so we have x equals 4, and we are done. That is a 3, 4, 5 triangle. Our next one, we have legs 4 and 6, and x is our hypotenuse. So we should do 4 squared plus 6 squared equals x squared. Well, 4 squared is 16. 6 squared is 36 equals x squared. 16 plus 36 is going to be 52 equals x squared. Here's why we did all that practice yesterday. You might, on the test, go, okay, I take the square root of both sides. We come up with x equals the square root of 52, and you lose at least half a point. You didn't do any math wrong, but square root of 52 is not simplified. There is a perfect square that goes into 52. And who can give me that perfect square that goes into 52? Yes. 4 is one of them. What's a bigger one? Okay, let me get the big one first. There's one bigger than 4. Oh, I'm sorry. I don't know. I was thinking another one went into it. No, it is 4. It is 100% 4. I was just trying to throw you guys off. I was making Jake like, wait, what? Because it'd be 4 times 13. For some reason, I was thinking 4 times 12 in my head, which wouldn't make sense because that'd be 48. No, it is 4 times 13, which is just going to equal 2 square root of 13, because you do the square root of 4 times the square root of 13. Okay, Labib.
How can you just get in the calculator, you put in 52, and then take the square root of that?
Do you get a big decimal out?
Yeah.
You lose a point on the test. Because I'm going to ask for the exact value. Like you're building a road or something. When they're building the road, they come down on a square root. They probably don't just round it off because every microcentimeter counts, right? We want to give it as exact as possible. So the more times you round, the less accurate your answer is. So the more you can keep it exact, like 2 square root of 13, much better. Questions on either one of those two? Cool. All right, our next one, once again, simplifying square roots is important because we have a leg that is 4 square root of 6. We also have a leg that's x. So we're going to start off by going, well, we'll have 4 square root of 6, the entire thing squared, plus x squared is going to equal 12 squared. Well, remember there's multiple ways to tackle this 4 square root of 6 squared. You can either picture it as being 4 square root of 6 times 4 square root of 6. What I kind of do in my head is I'm kind of picturing this 2 basically gets distributed to both of these items. So we can look at this as being 4 squared times square root of 6 squared plus x squared, and 12 squared is 144. Well, 4 squared is just 16. Who can tell me what square root of 6 squared is? It's not 36. Yes. It is just 6. Plus x squared equals 144. 16 times 6 is 60 plus 36, so that's going to be 96. Plus x squared equals 44. So we're going to have x squared equals, what was that, 48? Take the square root of both sides. You come up with x equals the square root of 48. 48 should scream that at least one perfect square goes into it. Well, perfect square for sure goes into it. Yeah. 16 goes into it. I was thinking we're going to get the 4 out, but 16 is a much better option. 4 goes into it, and if you do it, you just have to take 4 again. You're going to realize that you don't have a simplified fraction. So we're going to do 16 because it's much quicker. You guys are just too smart for me today. We're going to have 16 times 3, which is going to equal the square root of 16 times the square root of 3, which just equals 4 square root of 3. I believe I said this yesterday. Do I need to see every one of these steps? No, I just need to get the gist that you know what you're doing. It's a lot of steps to do when you're just like, in my calculator I can do 144 minus and get that all the way down. All right, last one's only difficult because our hypotenuse happens to be x plus 2, but you do the same stuff. Your legs are 8 and x, so we're going to do 8 squared plus x squared. Our hypotenuse is x plus 2, so make sure you do the entire quantity x plus 2 squared. 8 times 8 is 64 plus x squared. Now, here's what I don't want to see. And I see this even in pre-calc. I see people going x plus 2 squared is x squared plus 2 squared. That is not correct. The only time you can do that is if it's multiplication. It's a chain of multiplication, so I can kind of distribute it like that. X plus 2 squared is x plus 2 times x plus 2. It is that thing multiplied twice. So don't shortcut it. If you're someone that makes that mistake a lot, write it out a lot. The more you write it out like this, the more you're going to remember it. And when you get to algebra 2, you get to pre-calculus, you're going to be much more successful at doing it. Yes, John?
Would it still be correct to say x squared plus 4?
X squared plus 4? No,
Oh, why?
because this is not going to be x squared plus 4.
That would. Together they would, right?
They would not be together, because let's go ahead and do that math. So we have 64 plus x squared is going to equal. When you have a binomial times a binomial, you need to distribute. You need to distribute. So I'm going to distribute that x to both items in the other binomial. Well, x times x is x squared. X times 2 is 2x. That was just distributing the x. Now I have to distribute this 2. 2 times x is 2x plus 4. So that entire right side is going to be 64 plus x squared equals x squared plus 4x plus 4. So John, what you're missing is that 4x in here. That's why I did this example. Like I said, in pre-calc, people are still doing that. So how about you get a handle on it now? Then you get to algebra 2, you'll be much more successful at it because you're going to see more of that. And when we get to pre-calc, you'll be even more successful. All right, let's get all the x's on one side. So that means let's go ahead and subtract x squared from both sides. We are going to have 64 equals, the x squared is just canceled out, and I'll have 4x plus 4. Subtract 4 on both sides, you will have 60 equals 4x. So x is going to equal 60 divided by 4 is 15. X equals 15. Yeah, that's exactly why I did this one, because I know for a fact several of you out there are going to do the x squared plus 4, which hopefully this is just like, oh, okay, that's why I did it wrong. Make sure you write it out if you're one of those people. All right, any questions on this? All right, then let us go over questions from the homework. I know some people had some questions. Maybe it was the bell work. Yeah. 15? All right, 15. 15, we have square root of 70 times the square root of 42. Let me have my calculator on my at any time. So one way is to look to see if there's any perfect squares that go into 70 or 42, and it doesn't look like anything really goes into them evenly, so that means we have to do the multiplication, right? So we're going to do our 70 times our 42. So that's one way. I'm trying to think, is there a perfect square that goes in? 16 doesn't, 9 doesn't. Okay, we're good. So we're looking at the square root of 2940, right? All right, so our big thing is we're looking for a perfect square that goes into it. So it might take several tries because it's actually a big square root. I'm trying to remember which one goes in. Because 1,225 actually goes in, which actually is a perfect square. But what you're going to do is you're just going to slowly reduce it. So let me see what other ones go into it. So we have 2940. 2940. Maybe there isn't a good one. Maybe we could just do 4. Try 4. Because 4 works. It's just going to take a few more steps. So if I take out a 4, we're going to have a square root of 4 times 735, right? And then we're going to have, well, that's going to equal 2 times square root of 735. But more go into 735. I'm trying to remember which one goes into it. What is 9? Yep. 49. Oh, yep, it goes into it 15 times. So we're going to have 2 times 49 times 15. So that's going to equal, it's going to end up equaling what, 14 times square root of 15? Yeah. Oh, okay. I gotcha. But you seem to know all the elements, so you're good. Other questions from the homework at all? Questions from the homework going once? Twice? Just know, if you don't know how to do those, where you're simplifying them all, this is where you're going to lose point after point after point on the test when I'm asking you to do the squares. All right, while we're still talking, everyone turn to real quick to 15, 16, 17, and 18. All of those, you have to draw a picture. You have to draw a picture because it's going to make your life a lot easier. And more importantly, look at 17 and 18. They start talking about a rhombus. What do we know about all the sides of a rhombus? They're equal to each other. So if you make one of them x, they're all x's. If one of them is 4, they're all 4. So in fact, a rhombus is going to make a whole bunch of, it's going to create 4 right triangles that are the exact same. So a rhombus will always end with 4 right triangles that are all the same. All right. Go ahead and get started. Ask questions. Please ask questions.